we are now going to execute the LISP lab, configuring LISP in these three routers. We are going to configure LISP, but before that, we are going to configure the underlay protocol, which will be OSPF version 3. So we are going to configure OSPF version 3 here, here, and here as an underlay protocol. We are going to share the wide area network IP addresses and the loopback IP addresses for these three routers. We are going to share them on the global routing table. So we are going to share with this underlay protocol the IP address that corresponds to this interface, this interface, this interface, and this interface, and the loopbacks. Remember that this is needed because these will become the RLOCs for LISP. Then we are going to configure LISP as an overlay protocol here, here, and here. So this is a really small LISP network. So this is actually our only PE that lives within our LISP core, and we have these two CPEs. So given these are CPEs, they are going to perform the role of XDR. So this will be an XDR, this will be another XDR, and this will be our map server, map resolver, alt server, and PXDR. Now we are going to use LISP as a transport for our users VRF. So this local area network interface will be mapped to the users VRF. This other local area network interface will be mapped to the users VRF. This is actually one endpoint ID. This will be another endpoint ID. So we are going to map the VRF users to the instance 3000 within LISP. So in this way, we are going to be able to transport traffic for the VRF users from the CPEs to the PE without having to use data path virtualization. We don't need to do that because this is not VRF Lite. This is the shared mode VRF support for LISP. And finally, given we are using OSPF version 3 to provide support for the VRF users within all the other part of the network, we are going to have to do route redistribution. We are going to need to redistribute LISP EIDs that belong to the instance 3000 into the OSPF version 3 VRF. So let's do that. The configuration for OSPF version 3 is already done. For router C1, we are enabling the interface gigabit 3 with this configuration for OSPF, gigabit 2 with this configuration for OSPF, and loopback 0 with this configuration for OSPF. Now, we already have these neighborships up. These interfaces are participating in the global routing table. The same for router C2. This is the configuration for the loopback, and this is the configuration for the gigabit 1. We have this neighborship with router C1 up, and this interface is participating within OSPF version 3. The same for this router C3. We have this configuration for OSPF version 3, OSPF version 3 in gigabit 1 with this neighborship and these interfaces. We have a complete routing table in the global routing table. So that is what we need in order to configure LISP. So let's configure LISP now. Okay, first we're going to configure this router as an alt server. So we need a particular VRF for the alt service, and then we are going to configure the alt service. So this is the VRF, and this is the command for in order to make this router an alt server. And now let's configure this device as a map server. So this is the only configuration that we need. We are going to configure site 1 with this keyword, and notice that we are going to configure this instance for the VRF users. We are going to list the EID prefixes within this site. They belong to the instance 3000, and we use this command to enable this device as a map server. Now let's configure this device as a map resolver, so we only need to execute this command. Now let's configure this device as a proxy ITR. So this will be the commands. Remember that proxy ITRs need to use this partial map cache configuration. We are going to use instance ID 3000 mapped to VRF users, and we need to provide the IP address of the map resolver, which is this same device, and the proxy ITR is going to use this IP address as the source for map request to the map resolver. Now let's configure this as a proxy ETR. So we are going to configure this line. That's the only line in order to configure this as an ETR. Now given this is an ETR and ITR, this device now becomes a PXTR. Now let's create the VRF users and map the local area network interface to this VRF. So we are creating a VRF and we are configuring this local area network interface as belonging to this VRF. We are going to do the same on the other router. Remember that this is going to become actually an endpoint ID. So let's go for router 3. And this is just regular configuration. So let's go and configure LISP now. So let's configure now LISP for router C2. Remember that it is going to be an XTR, so we need configuration for an ETR and for an ITR. So let's do that. So this is the ETR configuration. We are using VRF users mapped to this instance. We are declaring our mapping for the EID to RLOC with a priority and weight. This is the other lines for an ETR. Remember that ETRs talk to map servers, so we need to use the IP address of the map servers, and this is the ITR configuration. This line, and this line. Notice that we are providing a default gateway for this instance using this command IPv4 use PTR and providing the address, the IP address or the proxy ETR. This is the default gateway for this VRF. So let's configure the same on router C3. Notice that I use this command login console 0 to avoid the LISP, most of the LISP warnings. So this is how we configure this as an XTR. So let's see the configuration. So we declare our mapping. This is the endpoint ID, which is actually the subnet that belongs to the local area network, which is this one. And this is the RLOC, which is my wide area network interface, priority and weight. They are related to the VRF users with this instance ID because this EID lives within the VRF users. We are providing a default gateway for this instance ID. So we have the ETR configuration and the ITR configuration. Now we can perform some commands. So for instance, we can do show LISP session. These are the XTRs that are maintaining a session with this map server. We could issue show LISP site to see the site registration table, which is actually pretty much the mapping database. So we have this site name and we have this EID that was registered by this XTR. We have this other EID that was registered by this XTR, and these belong to this instance ID, which is mapped to the user's VRF. We can use show Lisp site detail if we needed more information. So for instance, we have this prefix. This will be the ETR IP address. This is the locator. This is the priority and the weight. And we have this other EID. This is the ETR. And this is the RLOC. Now for the XTRs, we can, for instance, execute show Lisp instance 3000's IPv4 database. This is what we configured. We have this endpoint ID and it has this RLOC. And we could issue this for this other XTR. And we could issue, for instance, map cache. So this is actually the map cache. We will be adding entries as we ask the map resolver for information. So we could issue this. This is actually a cache that is empty. So what will happen if I pinged the other endpoint ID? So let's perform a capture here. So let's go here and configure a capture, and let's ping on the local area networks between router C2 and router C3. Okay, so this is the capture. We only have OSPF version 3 packets. So let's ping this. Ping VRF users. We are going to ping the other side that has this endpoint ID. In this case, the IP address is this. From our local area network IP, that should be 10.4.100.1. 254. So by doing so, we are going to perform a map request at some point, and we are going to receive a map reply, and we are going to populate our map cache. So now we have this entry that we didn't have before. The ping is successful. Now the map cache should be renewed here on the other side, because it works both ways. Now let's configure the last part of the lab, which is redistributing the Lisp EIDs into OSPF. Let's see what we have here in this router A1, which is it is a router that does not belong to the Lisp domain. So if we issue show IP route VRF users, and we look for this endpoint ID, not in table. So let's configure redistributing here. We are going to redistribute endpoint IDs into OSPF. So first we're going to do this command, and then we are going to redistribute into Lisp. So after doing so, it now appears. It should be an external network. It is E2. And what happens if we do the same here? It shows as L. Remember that L stands for, we actually are injecting these two from Lisp, and L should be listed here as Lisp. So we are redistributing endpoints IDs coming from Lisp into OSPF. So we are issuing this command within Lisp, and in order to redistribute these inside OSPF, we go to the OSPF configuration and perform redistribution, which is here. Redistribute Lisp. So these are the two commands that we need: export signed registration within Lisp and redistribute Lisp within OSPF. That's it.